Hello and welcome to section 3.4a. We are going to be solving exponential and logarithmic equations, and there's a bunch of different ways to do this, and this is like any other solving equation thing. So there's multiple ways of solving problems, and so we have to pick the best way that works for us and in the problem. So this first example that I'm going to give you guys is a way to solve the problem where this is just one log in the problem, and remember that the log with the base is equal to the exponent. So I could do something like, oh, well, I'm going to take 5 raised to the second power, because that's my exponent, should equal what was in here, just changing it to exponential form. So that is an option, is if you can. If there's only one log in the problem, then you should be able to change it to exponential form. I know that 5 squared is 25. And so now it's just an algebra problem once I get rid of the logarithm. And so then subtracting 25 across the equal sign, 0 will equal x squared plus x minus 21, if I subtract it correctly. And so then at this point I could either factor or use the quadratic formula to find out what is going on here. And in this case it looks like I'm going to have to use the quadratic formula to solve this problem, because the factors of 21, as far as I can tell, are either 7 and 3 or 1 and 21. Neither of those guys will subtract to get me 1x, so I'm going to have to go with the quadratic formula, which will be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and in this case a is 1, b is 1, and c is negative 21. So plugging in these values for x, so I get negative 1 plus or minus 1 squared is 1 minus 4 times a times negative 21. Make sure you're keeping signs, all over 2 times 1. And so x will equal negative 1 plus or minus the square root, that's 84 plus 1, so 85 over 2. And so those are my two solutions for this problem when I solve the equation, and that's what I was looking for. So then the next one, this one has logs on either side, so what I'm going to have to do is do a little, remember some of my expanding and of these, and so I'm going to remember that x to the negative 2, that this negative 2 out front is an exponent, so I could say log base 4 of x to the negative 2 needs to equal log base 4 of 9. And we've been talking about that a inverse operation of a log is the exponential form. And so what I can do to get rid of logs on both sides is make these guys the exponents of base, and the base that I would choose would be 4 in this case, because that is the base of my log. So if I make these guys powers, so 4 to the power of log base 4 of x and 4 to the power of log base 4 of 9 would cancel out the log bases. So I'm really left with x to the negative 2 equals 9, and so then that would mean that my value for this, well, this is a negative 2, so it's really 1 over x squared equals 9. And you could solve this however you like. I could multiply by x squared, so I'd get 1 equals 9x squared, and then divide by 9. And so I'm going to just move over here, and so then 1 equals 9 times x squared. If I divide by 9 on both sides, x squared will equal 1/9, and then I could take the square root of both sides. Square root of 1/9 will give me x, and it's plus minus, so that means that x could be positive or negative 1/3. Now let's think about logs here. Could we have a negative number for the log? I don't believe we can, so that means that the value that I'm looking for would be 1/3. X needs to be 1/3, so x taken to the negative 1/3 taken to the negative 2 power should turn it into 9. And so that's really what I have here. If I rewrote the problem, log base 4 of 1/3 to the negative 2 should equal log base 4 of 9. This is just a check. And so negative 2 means that this fraction is the wrong way, so it's really log base 4 of 3 squared, which equals log base 4 of 9, which makes sense that it's log base 4 of 9 equals log base 4 of 9. So these should check out when we do these problems. The last one, the reason I didn't check it was because it came out to be a weird quadratic. But in class we will be practicing more of these, so please come with your questions on solving these.